Hi,
That's it.
it's Mr. G. I'm here with Mark Balzarette. He's a shop teacher as well. Teaches at Bergen Community College. And
How you doing?
all right, in an effort for distance learning, we just want to review some of the work. There's some great DIY electric motors as a response to an assignment I gave out. Mark, you ready to help me check out some of the student projects?
Absolutely. Looks good. Let's go.
Okay, so just to introduce the project, this is the video I sent the students originally. Okay, hey, it's Mr.G. Hope you guys are doing well. Okay, I got a project for you to do. It's a challenge, all right? We're gonna make the handmade electric motor. Okay, we're gonna make it out of things that you have in your house, all right? All right, so I'm thinking about like AA batteries. I'm thinking the kitchen magnet. Okay, so you guys get the idea. And
Yeah.
I got some students that did the project, and this will be the second reaction video. We did one with Barbercheck, but now we're going to do one with Mr. Balzarette. So away we go.
All right.
All right, so starting from the top here. This student, what they did was they took a screenshot of the work of the video.
Mm-hmm.
Okay, and then they put a list of materials together.
Good.
And then got all the materials together. And then they, here's the coil. Now I wonder where they got that coil. Let's see, very sloppy, but probably got the coil from like a charger cable that they weren't using.
Okay. So they stripped wire out of a charger. Is that the idea?
Yeah.
That's what you figure they did.
Yeah. Yeah.
Okay.
That was one
Okay.
suggestion I made.
Yeah, I remember seeing that in the video. So that was a good idea too, actually, because that's something so many people would already have.
Right. I was just thinking what they had in the apartment, you know?
Yeah, that makes sense.
Okay, here's the paper clips to the battery. And then them setting it up. And what we're going to do is we're going to get down to the video. So this is kind of the end of the presentation for them. And that might be a magnet sitting there. I'm not sure.
Hmm.
Let's see.
I don't know what kind of magnet. I don't think I've seen one that was big and square like that before.
Well, a lot of these are refrigerator magnets.
Okay, but still, I haven't seen
Yeah,
anything
that is
quite
weird.
that big.
So then what I would do is click on this link, but I already have it queued up before I hit play. So I hope the video comes out good. This actually moved. So if you don't see it spinning, it's because it's like the computer's buffering or something like that.
Yeah,
all right, here we go.
okay.
Ready?
You get the idea.
All right, here we go. Here it goes. It's going to flip. It flipped. There it goes. It's spinning. It's spinning.
That's it.
Yeah. Did that come through the video?
A little bit in pieces.
Let's try one more time. Here we go. Okay. All right. Well, that's moving.
Yep.
Okay. All right. Good. So we tried our best with that. That was a pretty good one.
Mm-hmm. Yeah, right. that worked pretty well.
Okay. Here's the next one. Now, this one didn't work out, but it was just good to see the effort. Okay. Here's a list of parts. Here's their plate and, USB cable. Now, here's the wire they got.
I see.
Taped the battery to the plate. Made a coil. But you notice they didn't strip the wire.
Right. I'm just thinking that now.
There's no connection.
Sure. And even if there was, if they had stripped the ends of it, I'm concerned that, there's so little, magnetic flux that's getting to the wire. It's kind of maybe getting, diminished because of the thickness of the insulation on there, plus the extra weight of the insulation. The plastic insulation's heavy, and that might have helped prevent it from spinning. So, yeah.
Yeah, I would say
they probably would have been better off stripping the wire completely.
Okay.
So that's good advice.
That's what I'm thinking. That's what I'm thinking.
Yeah, I just wanted to show a mistake because, you know, it's a good effort. They get credit for it anyway.
Mm-hmm.
All right. Okay, this one here. This was a good one. Let's see. Okay, that's just screenshots of the video. Here's their materials. Now this one is called. It's like the one with the straight axle one.
Okay.
The vertical shaft. Here's their wire. They're starting to twist it up. And then there's it on top of the battery.
Mm-hmm.
I guess they're making the brushes for the coil now. And there's the final product, but here comes the video. All right, you ready?
Ready.
Okay, here we go. That one's cool. Yeah.
That's great.
Let's try it one more time. What do you think of the construction?
Well, it's effective. It's working. It's working.
Yeah.
And that's all that really counts here with this. I mean, I don't know how many style points you can give anybody, but you know, they made it work. They absolutely made it work. So I think that's pretty good. I know that this type of setup here, you really get a lot of heat built up on the battery because it's a dead short.
Yeah. Yeah. Okay. All right. So moving on. I thought that was clever. Okay, moving on. We got this one here. List of materials, paper clips and whatnot, collection of materials, coil, the paper clips.
Mm-hmm.
Setting
Now, how
it up.
did you instruct them to make the coil?
I asked
Did you
them
tell them to just
just
loop it or wrap it around something?
I did it around a marker, and then I did another. I finished it by pulling out the arms.
Oh, okay.
And here's, I'm not sure what that is, but here you go. Now this one has, the arm has a hook, which would not let it spin.
Oh, yeah, yeah. That's
okay. So here's the video right now. It does move a little bit.
Yeah.
All right,
But
here we
it's not
go.
going to spin.
No. Kind of reacts to the magnet. It did react.
Yeah.
Here, they're trying another magnet. Very little reaction here. And here comes another magnet. That one, they actually touched it. So it's hard to tell if the magnet affected it or if, oh, that one, maybe, not sure. It's hard to tell with this one, I'll be honest.
But it's not going to rotate anyway because they've got these hooks on the ends of the wires.
Yeah.
And that's the trouble.
All right, that's a good effort. All right, I'm going to click away from this one. Okay, last one. Now, this is not all of them. I'm just highlighting a few. So I'm sorry if I didn't get to, like, for the students to get to their motor. But these were just a few of them that kind of worked, and I thought we should just review them. So this is them. I think they're using a USB cable. They tried to find a magnet out of a speaker. You know, they a lot of headphone stuff.
Right, right. And they all have neodymium magnets in them too, so they're going to be very strong.
Interesting.
It's going to be a good, powerful magnet.
Wow.
Small, but they'll be powerful.
And this one has 2 batteries, so that's good.
Oh, boy.
Here's the coil.
Mm-hmm.
And they got a strange setup where the coil is actually resting on another loop.
Yeah, I see that.
Did you see that?
Yeah.
Okay, and here's the video.
I see it says here, the coil would get very hot.
Ah, that's funny. Oh, you saw that right here?
Yeah, he wrote it. Yeah, the coil would tend to get really hot, so I would try to make this coil spin before you could set up in flames. He said, I don't think you're going to get that far with it, but
Yeah.
it's definitely going to get warm. That's for sure.
Yeah. All right, so let's go to the video. Here we go. Thought that was some movement right there. Hold on. Oh yeah, it's reacting.
Mm-hmm.
Definitely reacting. There's another view.
No, I can't see from the picture, but I'm presuming that he's got these batteries going connected in the right direction.
Oh, okay.
You know, he doesn't have both positive ends connected to one side and both negative. You know that the student understands that it's got to be this positive to negative loop.
Right.
I'm assuming that they've done that correctly, but I can't see from the picture.
Yeah. All right, cool. So, yeah, that's basically it.
Well, I think the students overall did a very good job. I mean, some of them obviously had some issues, but overall, I think they did a pretty good job. So
yeah, that's cool.
That's really good.
Nice.
Very nice. Very nice.
All right. Well, I appreciate you joining us. If anybody wants to find some of your work, I mean, you teach a lot of stuff. Where do they find you? They can see some of the stuff on Instagram.
There's some projects on Instagram. They can check that out. There's more projects on Instagram than anywhere else.
Okay.
I have a YouTube channel. It's just under my name, Mark Balzarette, BALZARETTEMARK. And, there's only a couple of instructional videos on there. I've got some musical stuff there too. But, if they're interested, they could subscribe and then wait for, some more instructional videos, which that I'm working on. So this is just getting off the ground.
Cool. All right, cool. Thanks for joining me, Mark. And
anytime, you're welcome. That was fun.
So good luck to the students, and let's see what you guys make next week. All right.
That's right. Good luck, guys.
Okay, bye.
Take care.